Okay. Hi, everyone. It's Diana Sinton. I'm a project manager with iGuide, and I'm happy to welcome today Mohan Kolla, who's here with us from Florida International University. He's one of iGuide's climbers, and he's going to be talking about the work that he does with Hypercube-RAG and flooding. As a reminder, this is a regular Zoom meeting, so please keep your own microphones muted throughout. We'll have a chance for some Q&A at the end. If you're always welcome to write some questions in the chat, and we can get back to those questions at the end. This session is being recorded, and once it's been processed, we'll have it up on our VCO website. Uh, Before I stop sharing the iGuide screen, as a reminder, we have VCOs almost every Wednesday. So I put there some titles of some upcoming topics as well. Okay, so I'm going to stop sharing right now. And Mohan, it is all yours. Thank you
All
very
right.
much.
Thank you, Diana. Okay. So, good morning, everyone. My name is Mohan Kolla, and today I'll be presenting our research on fusing in situ sensing, remote sensing, and textual information for the prediction and characterization of extreme events. So, our work focuses primarily on addressing the complexities of compound flooding through a very specialized RAG framework, specifically the Hypercube-RAG system. Now, this project was made in tandem with Jose Fuentes, who's a PhD student at Florida International University, and he specializes in animations specifically. Now, for the purposes of this VCO, I will not be presenting his part of the project, but I will say that he did help a bit in terms of the algorithms that were used on my side. Additionally, my mentor was Dr. Leonardo Bobadilla, so I'd like to take some time to dedicate this work to him as well. So, to understand why compound flooding matters, we first need to take a look at the impact of compound flooding. These events lead to significantly higher direct property and crop damage compared to single source floods. Beyond the immediate destruction, they cause prolonged business disruptions and exponentially increased repair costs for affected communities. A quick example of this that we've seen in recent times was, at least in my home community of South Florida, was when Fort Lauderdale Airport completely shut down and thousands of flights were grounded, both domestic and international. Now, uh, our approach is built upon the GeoRag paradigm. So unlike standard RAG, GeoRag needs to retrieve multimodal Earth data like rasters or DEMs. They have to reason using physics and domain constraints and then generate very specific science grade outputs like maps and JSON summaries. Finally, they have to verify all of this information against the ground truth sensors and expert models to ensure reliability. And that's essentially what I've been trying to put together alongside the work that Dr. Jimin Chi has done on his hypercube. So the main problem that I'm tackling with my specific project is that current retrieval systems struggle with compound flooding because most of the critical information is extremely fragmented across unstructured text, scientific literature, and diverse sensor datasets. So our goal with this project is to develop a truly multimodal system that is going to unify all of these streams into a single explainable framework to support flood analysis. Now, if this project comes to fruition, it will drastically improve the ability to predict um, flooding in a with a hydrologically meaningful context. Oh, sorry, that slide should have been hidden. Um, So what is the hypercube itself? It's simply a way to manage this large data set because the hypercube is a multidimensional structure that organizes information along several axes, such as location, event, and theme. This is going to allow the AI to pull together related slices of data, such as sensor readings from Miami during Hurricane Irma, for some unified reasoning. Um, so the hypercube rags, like the solution itself, is by combining the structured storage of the hypercube with the reasoning power of the RAG, we can get a system that can flag conflicts between sources while also applying physics-aware checks onto the data itself. For example, the system could output um, a high risk alert by reasoning that the heavy 3 hour rainfall is coinciding with peak tide that would be expected in 2 hours. Now, this slide shows our pipeline, our updated pipeline, because in the previous one, this was my initial thoughts, like when I had first kind of created the project. Now, as I moved on, I kind of went into more detail, specifically from the retrieve information section. So from here, when a query is being told to the system, it pulls information from a knowledge base that comes specifically from the sensor data and the textual data, and then that knowledge base is being accessed by the LLM, but also with the actual like the entire sensor and textual data in and of itself. The knowledge base is specific information based off of what the hypercube has been telling us. Because again, remember the hypercube is based off of axes. So not only will the LLM be given, it's almost like telling the LLM, hey, we should pay attention to these very specific subset of data, but if you need any more, we have the complete list available to you. And then that in and of itself is the supercube RAG fusion and reasoning model that I've created. Now, the current system that I want to create includes a front end as well. And so in the construction of this, I've had to do some EDA along the lines of kind of figuring out, well, what does my data actually look like? And so this is what these next couple of slides are going to be on. So first, in order to test, is my project even working? I have to create some sort of benchmarking. And in order to do so, I created some QA questions manually using certain authoritative sources like NOAA and the USGS. And these include complex questions such as what hydrological conditions precede major compound flooding events? And these are some other examples. What is fluvial flooding and how can it combine with surge? Or why do compound floods often extend farther inland than expected? Now, if the LLM is able to answer these questions in a precise manner consistently, then I'll know that I'm on the right direction. Now, the first data set that I had used was this Science Daily text data set because one of the things that Professor Bobadilla and I wanted to kind of pursue was using news articles. And so for our text corpus, we initially scraped over 19,000 Science Daily articles. However, after reviewing and kind of sifting through the data, only 1% were directly relevant to hydrology and flooding. And so when I had run my initial benchmarking, it gave me less than desirable results. But now to improve this quality, I've integrated a specialized data set of 30 verified research papers focusing specifically on severe climate events in Florida and Texas. Um, Now, when I'm putting together this information into the hypercube, um, I have to do so in terms of the entities and the axes. Now, the six axes that I've chosen were location, date, the specific event that was occurring during that time, any organization that was part of the event, such as FEMA or the NOAA, any person related to that event, specifically any meteorologist that was covering the event, and then the theme. The theme is one of the stranger ones, but I had to kind of create a miscellaneous axis for to cover almost anything else that had to go along with the idea of flooding that could be found in any article. Okay. And when I was putting together the sensor data, um, for the purpose of this project, the sensor data is not being put into the hypercube itself. Rather, the hypercube is going to point to a specific um, physical data set on my master list of the CSV file. Now, this is the master list here, um, and it shows half-hour increments per every station in Florida. And there are 28 stations, and so for every half hour over the course of all of 2024, it ended up being over 1.5 million data points. And so here's just a quick physical data overview. And we can see that the specific data sets that I used were iMerge, MRMS, and co-ops. And the study periods for all of this was all of 2024. And essentially, the reason that I wanted to use these specific data sets were because I live in Florida. And so I understand like the locations for most of these. Um, and yeah. And here's just a quick example of some of the co-ops, the title data that occurred specifically within um, October to, excuse me, uh, sorry, September to October. And the reason that I included this specific month is because this is essentially when it starts going from summer to fall, like the cycle kind of changes. And we can clearly see how the difference between Pensacola and Cape Canaveral. And for those of you that are joining us from outside of Florida, Pensacola is on the west coast, so towards the Gulf of Mexico side, and then on the other side, Cape Canaveral, which is on the Atlantic Ocean side. And we can see here the major difference between the two is that the tides change much more drastically on the Atlantic side than they do on the Gulf side, which is an important factor, which I'll get into in a moment. Now, for my overall data visualization, when I put together the information and ran through the data, we can see that large-scale precipitation events do not occur that often. Generally, they're concentrated around October and June for these events to occur, and storms are more frequent in the northwest sector of Florida. And if you give me just one moment, I'll show you this data visualization that I had created to kind of show essentially how the storms looked during 2024. Now, the bigger the circle, the more storms occurred during that time frame. And if you click on it, we can see exactly how many storm days there were. Storm days are essentially any days in which we get over 50 milliliters, 50 millimeters of rain. And so we can see here in the upper northwest, this is essentially where we can see the majority of the storm events happening. Now, as I kind of go back to the previous slide, as I go back to the previous slide, the reason that this is important to notice that the tides change slowly in the Northwest shows that water lasts longer there than they would in the Atlantic, where water kind of ebbs and flows more with more frequency. Um, and this is another a heat map that I had created to see, well, I know that I'm trying to figure out like how these flooding events occur. Well, how much do each of the kind of data points interact with each other? So in this case, we can see that the wind and the precipitation don't really affect each other, which makes sense because it's only um, a it's only a point 18 correlation. But we can see here that the lags, definitely we can see what happens 3 hours after um, affect each other far more. Okay. Now, why is it important to kind of have this cross data interpretation for compound flooding? Well, the main purpose of this joint analysis is to kind of understand the relationships between all of these data points and additionally prepare these features to be read by the hypercube. And so if it's able to detect certain conditions where the rainfall, the tide, and the wind coincide together, well, that poses as a greater compound flooding risk than any one factor itself. And some specific highlights that I also want to mention is that both iMerge and MRMS show similar dry dominance. So meaning that it's mainly not going to be raining, but then there are occasional extremely heavy bursts, which we need to look out for. And the co-op's water level was completely irrelevant or completely separate from the amount of rainfall that was falling. The rainfall didn't affect the water level as much as the tides did. And so this is our first evaluation iteration, and it gave us a pretty big finding. It showed us that the text rag provided, specifically with the Science Daily articles, provided no improvement due to the irrelevant text corpus. However, our multimodal system, which included the sensor data, created a significant improvement, proving that sensor data is essential for grounding the LLM's reasoning. Now, this is the one thing that I did not include here because I'm still currently running benchmarking for is the the article data because it was taking me quite a while to parse through the information. But I'm currently running benchmarking this week, and I should have more information um, by this weekend. Um, and going forward, one of the things that I had changed or for this data set was um, the sensor data is now going to point specifically towards the CSV format, which I had mentioned earlier. So next steps, I want to find alternative news data in addition to the Science Daily, simply because more information is always better. And to improve the benchmarking system for it, I want to improve the chunking for the RAG because I believe that there are certain aspects that could be improved simply by the way that the LLM is receiving the information. And so I want to improve my code on that. And I want to continue doing both of these things to improve the benchmarking. And then finally, I want to create a front end for users so that this could be a workable project, as this is part of my capstone project for my master's. And so part of it is that I do need to create a front end for users. Um, so some of the challenges that I faced during the creation of this project is that automation is going to be unlikely as a one-person team, at least, due to most of the government data sets not being updated in real time. And so there's simply no way for me to get real-time, um, what do you call it, weather data without paying um, an exorbitant fee. And then additionally, the lack of text data on southern US flooding events um, does not promote uh, proper benchmarking when it comes to the news articles, which is why I've been trying to improve that section. Uh, some future work that I wanted to create, I wanted to create if I had had more time, would be to add in image data capabilities so that it could, I could upload specific like topography maps of the water, and then the LLM could kind of compare that to sensor data. Additionally, embedding it within a neural network to make it even more robust would make this a lot better. Okay, and these are some of my references, and now I'll open the floor to questions.
Thank you, Mohan. Could you put it back, maybe for some of our, while we have some time for discussion or questions, let's put it on yeah, something that, um, well, one of my questions right now, actually, this is a good one
Hmm.
for this one question I've got. I'm wondering, you're a student in computer science, right?
Yes.
So how has it been? I mean, this is part of what iGuide works on a lot is we have most of our activity is at this intersection of computer science and some physical science um, data, whether it's hydrologic or atmospheric or,
Mhm.
come from so many different sources. How has it been? Was this one of the first times that you've worked with a lot of data from these sources, from these government sources?
For me, yes, this was the first time that I've worked with these government sources, specifically the satellite data. I've worked
Uh-huh.
with just basic, like the co-ops was fairly straightforward to get like the tidal data and the stations. But when it comes to the iMerge and the MRMS, the issue is that they all come from different government branches or
Right,
different government departments. And so none of them speak to each other.
right.
So when it comes to their information, I have to be able to convert, what do you call it, several different file types all into one, and it makes the coding process so much more painful than it has to be.
Plus, I mean, the nature of those data formats themselves
Hmm.
are frequently specific for that, that type of data. So you've had to grapple with a lot of different spatial formats that
Yeah.
that were actually, may have never been intended to have become merged together, or, the interoperability of all of these is definitely a challenge, right?
Oh, absolutely. And uh, if I am ever in a position of the government here in the United States, my first act will be to make sure everything is standardized throughout all of the science branches because working with these was a nightmare.
Yeah. Yeah, it's there are what, having data standards, iGuide works a lot with the Open Geospatial Consortium to have to make sure that our platform tries to uh, support the data that we have on the platform with different standards, and but it's certainly super complex given the range of spatial data formats and
Hmm.
spatial resolutions of everything, spatial and temporal resolutions. Any questions from the audience about this work? Mohan, are you finishing up your master's work this academic year?
Yes, I'll actually be finished next month.
Okay. Are you looking for, going forward, are you looking for an opportunity to work more with these types of geospatial data sets?
Generally, I hope so. But my thing is that hopefully I will be more so in industry working with these data sets
Hmm.
rather than academia. But going forward, I definitely want to stick to environmental data sets.
Hmm.
That's my goal.
Yeah,
There's a company actually out in Michigan who works with the Great Lakes, and I definitely want to pursue river data and lake data from there.
there's some excellent work being done. Yeah, there's many different entities that focus just on the Great Lakes. That's really interesting that that's an area that attracts you.
Mhm.
Sina has a question. I see a hand raised.
Hi, Sina.
Hi, Mohan. Thank you for a great presentation and thank you for highlighting the importance of these standards that are not sometimes there and these
Mhm.
data sets not talking to each other. Have a general question from you.
Yes.
And that's regarding the data sparsity. So, I see that you worked with some temporal data. There are
Hmm.
sometimes data gaps, and the gaps exist. Like this data exists, the other one doesn't exist. You have
Hmm.
satellite imagery that have cloud cover. Some
Hmm.
days you don't get that data. Uh, how did you deal with this?
So within at least the data sets that I had used, most of them did cover all of 2024, every single day. Especially iMerge and MRMS, they were 100% there for, I didn't have any missing data, which was surprising, I know, but no, it was wonderful. And then as for the co-ops, that one they simply put a sensor in the like coastal area and they're simply just measuring it every half hour. And so, for the purposes of this specific data set that I was working with, I luckily ran into no issues on that regard. What I did run into an issue, though, is that there is no data for 2025 with iMerge and MRMS because the information isn't given to the public in real time. So the government has the data, they're simply just not giving it to the people.
I see. Yeah, probably the reason for it is that in order to make that, they need to do a lot of post-processing to make
Hmm.
sure that such a gaps does not exist. Which is interesting that you didn't see any of those gaps, which normally, at least in my times, used to exist, but that's ages ago, I guess. Yeah, another question that I have from you is that uh, have you ever looked into a concept called geodata cubes? You mentioned hypercubes, and hypercubes to me is a mathematical model, so it's
Hmm.
not like a more of a data model, like it's not a really database oriented. So I was just wondering if you have ever heard about something like that.
So in my research, I don't believe that we went over geospatial data cubes. Um, I believe that this is essentially what Dr. Jimingshi's research was built upon, but I didn't really 100% go further into his back end part of it. Rather, I focused more so on an application for it.
Thank you. Thank you, Juan.
Dina, were you thinking that the data collected here from iMerge and MRMS, that these are frequently data that end up being interpolated or extrapolated to make a surface?
Yes, I
Yeah.
do. So, and the reason so if you don't face so the biggest problem here is that the data gaps, right? Especially if you
Hmm.
deal with the satellite imagery, like cloud cover, right?
Right.
It's sometimes you can't use the satellite imagery. If you do not have a structure that can handle the sparsity of the data, you will have issues, right? But if you
Hmm.
have a very homogeneous data that exists all around all the time, every minute that you want, or in the time scale that you want, hypercubes, it seems it worked. So
Hmm.
that's
Hmm.
why I brought up the question. And the difference would be, so the geodata cubes, you can kind of consider it as a subset of a hypercube.
Hmm.
But so yeah, if you have this case that you don't have a data sparsity, you would not see any reason to go to a geodata cubes. I that I
Right.
can understand. Yeah.
So the point that I also want to mention is because the cloud cover specifically, it's not really going to affect my data simply because the satellites can still see the rain. Like because there's clouds, the rain in and of itself is going to create like that Doppler effect. And so that's what they're measuring. So even if there's cloud cover, even if like a massive plane or like a big metal like thing is blocking it, they can still like I guess like measure the rain, how it's like falling.
Well, if NOAA released such a data, they definitely calculate it based on
Hmm.
some credible, models. They're
Hmm.
doing it for years. And MRMS, yeah, that's right.
Yeah. All right. Thank you for that discussion. Sina is one of our colleagues with iGuide who's part of the Open Geospatial Consortium. So had a chance to remind a lot of our activities, inform a lot of our activities from the perspective of geospatial data and standards and interoperability.
Hmm.
All right. Well, if there aren't any other questions right now, I want to thank you again, Mohan, for sharing your research with us. This recording will be processed and we'll put it up on our website. And good luck finishing up your graduate work. And good luck with that work in the Midwest too. Be exciting place to be.
Yep.
All right. Thanks, everyone. Stay tuned to the iGuide VCO calendar schedule. We'll have many more coming up. Take care. Bye,
Thank
everyone.
you.